Hi guys, maayong adlaw. Welcome to NatzMath TV. So for today's video, my presentation is about division of radicals. We are done with addition, subtraction, and multiplication of radicals. So this time, we will have division of radicals. So how do we divide radicals? But before that, we need to remember that when we divide square root of a divided by the square root of b, this can be written as the square root of a over the square root of b, which in turn is equal to the square root of a over b, where our a and b here are non-negative numbers and b should not be equal to 0. Why? Because if b is equal to 0, this will make the whole fraction undefined. So b should not be equal to 0. So how do we divide radicals? When we divide radicals, there's only one thing that we need to remember. We have to see to it that the index are the same, just like here. Square root of a divided by the square root of b, our index is 2. Again, reminder that if in a radical expression there is no index is being indicated, that means the index is 2. So in this case, our index here is 2. So we have to see to it that the index are the same. Okay, let's proceed now to our examples. When we divide square root of 50 divided by the square root of 2, of course, we can write this one as the square root of 50 divided by the square root of 2. In this case, since the index are the same, since they are both square roots, so we can just simply divide 50 divided by 2, which is equal to 25. So this is equal to the square root of 25. And since 25 is a perfect square, and the square root of 25 is 5. So therefore, our answer is 5. Okay, another example. If we are given 6 cube root of 15 divided by 2 cube root of 5. This time, the index is the same. We have here 3 and 3 since they are both cube root. So we can express this one in a fractional form as 6 cube root of 15 divided by 2 cube root of 5. But I would just like to remind you that when we divide radicals, you can just divide directly the square root of 50 divided by the square root of 2, which is the square root of 25. In this case, I just have shown here that this expression can be written in a fractional form. So the same here, we have this form. We can express this one in fractional form. So we have 6 cube root of 15 over 2 cube root of 5. So since the index are the same, we have here 3 and 3. So we can just divide 6 and 2, 15 and 5. So our 6 and 2 here are called the numerical coefficient. So we just simply divide 6 divided by 2, which is 3. Then we copy the cube root. Then 15 divided by 5 is also 3. So since 3 is not a perfect cube root, so this is now our final answer, 3 cube root of 3. Another example. For example, you are given the square root of 8x cubed divided by the square root of 2x. So this expression can be written as, in fractional form, we have the square root of 8x cubed, which is this one, that is divided by the square root of 2x. Now, since we have here a variable, so we just simply divide, of course, our constants here, which is 8 divided by 2, since they are the same square root. So divide 8 divided by 2, we have 4. Now we apply the rule in division of polynomials. So we have here x cubed divided by x. When we divide variables, we just simply subtract the exponents. So here, our exponent here is 3, and here our exponent is 1. So we copy the x, and we subtract the exponent 3 minus 1, so that's why we have here 2. Since the square root of 4x squared, 4 is a perfect square, and x squared is also a perfect square. How did we know that x squared is a perfect square? If the exponent of the variable, in this case, which is 2, is divisible by the index here, since our index here is 2. So therefore, our final answer would be the square root of 4 is 2, and the square root of x squared is x. So because we divide 2 divided by 2 is 1, so we have here an assumed exponent 1. So therefore, our final answer is 2x. Let's proceed to another example. So this time, this is a more challenging example. So we have here 125a raised to 4 cube root of 40a divided by 25a cube root of 5a. So we have here this coefficient of this radical, another coefficient of this radical. So we write this one in fractional form as 125a raised to 4 cube root of 40a divided by 25a cube root of 5a. So we divide 125 divided by 25 is of course 5. Then we have here a raised to 4 and we have also a. Apply the rule in division of polynomials. So we copy a. Then we have the exponent here is 4 and of course the exponent here is 1. So we just simply subtract 4 minus 1 which is 3. That's why we have here the 3. Then in the radical we copy the cube root of since they are both cube root. Then we divide 40 by 5 which is 8. And this time we have here the a. We have a in the numerator and a in the denominator. So they are both have the same exponent which is 1. If they are the same, we just simply cancel out. We have 8. That's why we only have here 8. So we can cancel out a and a. Now, since 8 is a perfect cube root, okay, cube root of 8 is 2. That's why we have here, we copy 5a cubed times the cube root of 8, which is 2. Because when we multiply 2 3 times, that gives us 8. That is 2 times 2 is 4. 4 times 2 is 8. That's why our cube root of 8 is 2. Then we multiply this 2 to 5a cubed. So our final answer would be 10a cubed. Okay, another example. We have the fourth root of 162 divided by the fourth root of 32. Now this time, since 162 is not a perfect fourth root, the same as with 32, so we just simply factor out 162 and 32 in such a way that one of the factors will give us a perfect fourth root. So we write this one in a fractional form. So we have the fourth root of 162 over the fourth root of 32. So therefore, we find the factors of 162 and 32 in such a way that one of the factors is a perfect fourth root. And these numbers are, for 162, this can be factored out using the numbers 81 times 2 because 81 times 2 is 162 and 81 is a perfect fourth root. The fourth root of 81 is 3. The same happens for 32. 32 is not a perfect fourth root, but we can factor this out by using the number 16 times 2. 16 times 2 is 32, and 16 is a perfect fourth root, which is the fourth root of 16 is 2. This time, we get the fourth root of 81, which is 3. That's why we have here the 3. And what remains in the radical would be the fourth root of 2, because 2 is not a perfect fourth root. The same happens for 16. The fourth root of 16 is 2. That's why we have here the 2 outside the radical. And what remains in the radical is the fourth root of 2. This time, we have here fourth root of 2 and fourth root of 2. So we can cancel this out because they are the same. So what shall remain as our final answer is 3 over 2. So this is now our final answer. Now let's proceed to our last example. For example, you are given, this is already in a fractional form. The square root of 4 over 2 square root of 20. Remember, 4 is a perfect square. So the square root of 4 is 2, so we can write this one, 2, which is the square root of 4. Then we have here the 2, we copy the 2, and 20, since 20 is not a perfect square root, that's why we factor out 20 in such a way that one of the factors will give us a perfect square. And that factors are 4 and 5. 4 is a perfect square. Then we simplify further. We copy the 2 in the numerator. We copy this 2 here, which is this one. and the square root of 4, which is 2, so we place this one outside the radical. That's why we have here the 2. This is now the square root of 4. And what remains in the radical is now the square root of 5. Then we multiply 2 times 2, that gives us 4. So the fraction becomes 2 over 4, the square root of 5. Now, a fraction should not contain a radical in the denominator. In this case, we have here the radical, which is the square root of 5. We have to see to it that in our final answer, should not carry a radical expression in the denominator. So what do we do is just simply rationalize the denominator. So the process of rationalizing the denominator is to eliminate the radical symbol in the denominator. So how do we rationalize? In this case, in our example, we have a radical in the denominator, which is the square root of 5. So to eliminate this radical in the denominator, we will have to see to it that this will become a perfect square. So we think of a number that we multiply to 5 that will become a perfect square. And of course, that number is 5 because 5 times 5 is 25 and 25 is a perfect square. So therefore, if that is the case, we will multiply both the numerator and denominator by the square root of 5 over the square root of 5. We did not change the value of the fraction here because this is just equal to 1. So square root of 5 over the square root of 5 is equal to 1. And any number multiplied to 1 is the same number. So therefore, we just simply multiply this number to 1. So we did not change the value of the fraction. Our focus is to eliminate the radical symbol in the denominator. We can have a radical symbol in the numerator but never in the denominator. That's why we have to rationalize the denominator. So in this case, we multiply both the numerator and the denominator by the square root of 5 so that we can have a perfect square in the denominator. So this becomes 2 times the square root of 5, of course, that is 2 square root of 5. We do not multiply 2 times 5 because 2 here is constant. This is not a radical. So we just simply multiply 2 to the coefficient here of 5, square root of 5, which is 1. So 2 times square root of 5 will give us 2 square root of 5. Then over, we copy. 4 times, we have here 1. Of course, 4 times 1 is 4. And square root of 5 times the square root of 5 is the square root of 25. Now, since 25 is a perfect square, so we can extract the square root of 25, which is 5. So we copy the numerator, 2 square root of 5 over. We have here 4, copy 4, and the square root of 25 is 5. So that's why we have 4 times 5. Then we multiply 4 times 5, we copy the numerator, 2 square root of 5 over 4 times 5 is 20. This time, we have the constant here, 2 over 20. 2 over 20. We can simplify this one, but we cannot simplify 5 over 20 because 5 is in the radical. We can only simplify 2 over 20, which is we divide by 2 over 2. That will give us, we have here 1, or square root of 5 over 10 because 2 divided by 2 is 1. Here, assume 1 here, and 20 divided by 2 is 10. So our final answer is square root of 5 over 10. So we cannot simplify this fraction further because, again, as I've said, the numerator is a radical and the denominator is a whole number. Again, as I've said, this process is what we call rationalizing denominator. Okay, that's it. I hope you have learned something from this video. Thank you and God bless.